Yeah.
So maybe we'll start. Thank you everyone for coming to the talk. It's my great pleasure to introduce Daniel, who is a professor of computer science at MIT. Among many different things, he's well known as the creator of Alloy, which I know many of you here actually learned and used in this semester.
Don't blame me.
As well as his work on software dependability and analysis. And recently he started working on a very interesting direction on conceptual design of software. And he actually has a book that came out last year. It's called Essence of Software, which I highly recommend if you haven't picked it up yet. And he's going to tell us more about his work today. So, it's Daniel.
Thank you so much, Insuk. It's so much fun to be here. I actually started out my career as a professor here at Carnegie Mellon, had many wonderful years here. So it's really great to be back and to see some old friends. So in a way, I was trying to think about how to frame this talk for a Carnegie Mellon audience. And I just realized last night that in some ways, I've taken a kind of strange personal journey. You know, I started out as a software engineer and became a devotee of formal methods. We were just chatting with Insuk and David Garland last night about Z and how much we all loved Z. Z was this specification language developed at Oxford by Jean-Raymond Abrial, Tony Hoare, Michael Spivey, and others. And there was a terrific book called Specifications Case Studies, which sort of appealed to me as a sort of formerly physics undergraduate that seemed to be sort of reducing software to these beautiful little incantations. And I loved it. But then over time, I became a little disenchanted with the world of formal methods. And I became much more interested in design questions. Like many people in the world, I became a devotee of Christopher Alexander, mainly through Notes on the Synthesis of Form, but also through Timeless Way of Building and his later books, which I think are very interesting. And then, of course, inevitably, Don Norman and his Psychology of Everyday Things with the beautiful acronym POET, which later sadly became DOET, which didn't work quite as well as he switched the name from psychology to design. And recently, I've really felt that I'm interested in the problems of the HCI community and what it means for software to be usable, and realizing that robustness and security and safety, I mean, this is not my observation, I think it's well understood, are all tied to the concerns that the HCI community has addressed at the interface between humans and technology. But what I've found is that as I've thought about this, perhaps inevitably because of my own biases, I sort of returned to my early days. So in some ways, if you want a sort of one-line summary of the talk, you know, this is the point where you can sort of say you've got everything and you can take your lunch and leave. You know, in some ways, this talk is about bringing some early ideas of formal methods to HCI, sort of semanticizing the user interface. So in some sense, I sort of feel like, you know, T.S. Eliot in his poem, that I've sort of arrived again where I started, but knowing it for the first time, perhaps in a different way. One of the things I've been doing is I've been trying to read quite carefully and understand quite as deeply as I'm capable of, you know, what some of my favorite authors and influential books have been saying. And I came to realize in the last few months, as I was thinking about how to explain these ideas to students in my software design course, that I completely misread or largely misread a very important book, and that is Don Norman's book. Now, Don Norman in his book, at least in the latest edition, in all his editions, he sort of summarizes the key points at the beginning. In the latest edition, he provides, you know, an outline of what the big ideas of the book are. And they're things we're familiar with, like the idea of affordances and constraints and mappings and so on. And then he says, but there's a sixth principle, perhaps most important of all, the conceptual model of the system. It's a little unclear why a model is a principle. And he says the conceptual model that provides true understanding. And I've been trying to make sense of what he meant by this. Let me show you Don Norman's canonical example of a conceptual model, because I think it's very interesting and insightful. So he points out that many fridges in the States are still designed like this. My fridge is designed like this. And it's kind of amazing because it's catastrophic. You have these two controls, one marked freezer and one marked refrigerator. And you might think some of them are a little better. They actually say warmer, colder on the dials themselves. This has a slightly weird arrangement. But either way, you might think this is a fairly straightforward thing to control. And the reason you might think it's straightforward is because this is the model you have in mind, in which basically there's a thermostat in each unit, and each of these controls a thermostat. But as he points out, in fact, the engineers have skimped on having two thermostats and two compressors. And instead they have a single thermostat and a single compressor. And what the freezer one does is determine the amount of cooling, essentially. And what the refrigerator one does is switches cold air between the two compartments. Needless to say, this is incredibly confusing. And Don Norman rightly points out that this user interface completely fails to explain what the underlying conceptual model is. And he has this very nice notion of the system image. And one of his ideas, key ideas, is that a user interface should project a system image that essentially teaches the user what the underlying conceptual model is. And I have to admit, when I read this, as I think we all do, I read into it a whole load of things that Don Norman did not say. And I've come to realize that the one thing I read into it, which he did not say, or at the very least said only obliquely and without much conviction, is that this design is just terrible. It's nothing to do with user interface, right? Even if you knew, if you knew this conceptual model perfectly, even if you understood this, you still wouldn't be able to control the fridge. And the reason is that you can't control the compartments independently. And worse than that, being a fridge, it takes about 24 hours to settle. So it actually becomes a major engineering exercise to make your ice cream freeze without freezing your lettuces. Because if you turn down the freezer a little bit, now you're freezing the fresh fruit compartment, and you need to turn that down a little bit, and you need to sort of get into some feedback loop. And whether you know the conceptual model or not, in fact, is largely irrelevant in this case. But if you read Don Norman carefully, this is still his focus. He says, but with the wrong conceptual model, it's impossible to set the controls. And my observation is, with the right conceptual model, it's impossible to set the controls. So what's going on here, the way I understand it, is that the user trying to use this system has some concept of the system. The designer has some concept of the system. And of course, the user has to understand the designer's concept, but there's no telepathy. And so, as Don Norman wisely points out, instead, that has to be conveyed in this sort of little commuting diagram through the right-hand side of the diagram. The way I understand classic usability research is that it's come at this from the user's side, saying, what does the user understand about this concept of the designer? And it's interesting that the field of user-centered design with people like Don Norman and his colleagues grew out of psychology research. And as I mentioned, the book was originally called The Psychology of Everyday Things. And actually, I think that should be the title. And it's very misleading. It perhaps sold more copies by turning it to the design of everyday things, but that's not what it's about. It's about psychology with a little bit about design. And I think that was a huge insight because, as Don Norman put it, if people don't know how to use your machine, then the machine isn't useful, right? And so psychology, this was a great insight to bring psychology to play. But at the same time, I think in some ways, it was only one side of the story and perhaps not even the most important side of the story. And so the question I ask is, what if the design model itself is just wrong? In that case, maybe we want to come from this side instead, thinking about what the conceptual model should be, rather than how the user perceives it. And in fact, much early work on conceptual modeling does emphasize this point. And so the way I would put it in the bluntest terms is that conceptual model is really the wrong phrase. There is a conceptual structure, which is the software. It's not an understanding of the software. It is the software. The user has a mental model, and that mental model might diverge from the actual conceptual model. And that's clearly a problem that needs to be remedied. But software is a conceptual model. And I've realized more and more how much I diverge from Don Norman on this. Don Norman, for example, in talking about a computer says, of course, there aren't folders and files inside the computer. And I would differ. I would say there are folders and files inside the computer. And that's exactly what we learn in software engineering classes with abstraction functions and so on. They're just represented in a way that makes them perhaps not immediately apparent if you were just examining the bits. So let me show you a software analog of Norman's fridge. This is an example that I find kind of instructive and amazing. And it has a similar quality of a sort of very widely used device that has some problems. I saw this many years ago and I loved it. Someone said, someone accidentally deleted thousands of files in my company Dropbox. How can I quickly undelete them? And what I love about this is because they're so betrayed that they're not a computer scientist. Because if they were a computer scientist, they would never have such optimism. The question would be, is there any way on earth that I could get any of this stuff back, right? But no, they want to quickly undelete them. So how do these kinds of things happen? Well, here's how. Here's Ava. She's a party planner. She's planning a party for Bella. She sets up a Dropbox with a folder in it called Bella Party. She shares it with Bella. Bella looks at her Dropbox and says, Bella Party, I'm Bella. That should be called My Party. So she goes to rename it, and she renames it to My Party. And now the question is, does the name change for Ava too? So let's take a vote. What do you think? How many people think the name changes for Ava? Okay, how many people think the name does not change for Ava? Okay, the changes win, but they're wrong. Ava doesn't in fact see any change. Let me ask you a different question. Suppose Bella Party has a folder in it called Bella Plan, and Bella goes and says, well, I'm just going to change the name of Bella Plan to Party Plan. And so I'm going to ask you again, how many people think the name of Bella Plan is going to change? How many people think it won't change? Okay, so a few have shifted here. So the answer is, in this case, yes, it will change. So I would say, whether or not you understand the conceptual model here, this cannot be good behavior, right? Because what we have is a strange non-uniformity that depends on observing a very subtle property of the structure of these folders. It is actually hard to see, right? Which is at what level the actual sharing occurred. And if you think, well, name changes aren't a big deal, the problem is the same thing happens for deletion. That if you deleted that folder, Bella Party, it would in fact not delete it from Ava's account. But if Bella deleted Bella Plan, Ava would lose it too. And this, I suspect, is why people lose files on Dropbox, because they don't understand this distinction. And notice, by the way, here's something I think Don Norman definitely wouldn't like. There's a long explanation about the deletion of Bella Party, reassuring you that if you delete it, that Ava won't lose it. But in fact, the long explanation is needed here, or maybe a big message in big capital red letters saying, if you delete this, all your friends who are sharing this will hate you forever. And so the problem here, in short, is that users believe that this is the folder concept, where basically there are folders that have names on them and folders contain each other. That's not what's going on. And I don't have time in this talk to explain this in detail, but would be happy to explain it to you offline or perhaps in questions at the end. But in short, following the thread of Unix and Multics before it, in fact, the way things work is that the names of folders are really attached to references to those folders. And so the reason that Bella Party doesn't change is that Ava and Bella have their own copies of that label. And yet there's only one copy of the Bella Plan label. Now, however much I explain this, I don't think understanding this really helps. It's simply the wrong model. And so to me, it's like Norman's fridge. It's like there is no fix to the Unix folder model that makes it actually as usable as it might be. Explanation will not help. Apple, interestingly, whose operating system, Mac OS, experiences all these problems, tries to work around it by imposing some constraints that prevent you from observing these things. It's quite clever. So anyway, so I was really interested in the question of, well, what are these concepts about? Can we actually make sense of it? What is software design all about? And for me, this goes back to a wonderful piece that Mitch Kapoor wrote. It actually originated as a kind of sermon that he gave to a group at a forum of tech CEOs that Esther Dyson hosted in the 1990s. And he posed this question. He said, and this is sort of the question that makes my engineering colleagues very upset. He says, when you go to design a house, you talk to an architect and not an engineer. Why is that? And the answer is because the criteria for what makes a good building fall outside the domain of engineering. Now, of course, this isn't to say engineering doesn't matter if the building won't stand up, right? It doesn't matter how pretty it is, how lovely the spaces are, how usable it is, right? But the point is that engineering is at best half the story. And the question for me is, what is the architecture in this sense viewed by the user of a software system? And of course, I have to use the word architecture here at Carnegie Mellon very carefully because David Garland and Mary Shaw pioneered this wonderfully insightful and revolutionary view of software in software structure in terms of architecture. But here it means something slightly different. It means architecture in the perception of the user. And so Kapoor asked, He said, similarly, in computer programs, the selection of the various components must be driven by the conditions of use. How is this to be done by software designers? Now, his goal was actually to advance the role of software designers. He wanted every company to have a role called software designer. And that hasn't happened. We have product managers, we have UX designers, we have visual designers, we have software engineers, we have software architects and so on, but we don't really have software designers. And the reason I think for that is that we haven't really figured out what software design is, at least in these terms. And that's really what I'm trying to explore. And it seems to be something about the conceptual structure that's perceived by the user. And this idea is an old one, and you find it repeated again and again in different kinds of communities. So for example, Fred Brooks in Mythical Man Month explains conceptual integrity is the most important consideration in system design. The essence of a software entity is a construct of interlocking concepts. And so that you couldn't actually refute him on this, he never actually told you what concepts were or conceptual integrity is, which I think is very interesting. Don Norman, likewise, as I mentioned, says, perhaps most important of all is the conceptual model. And interestingly, he says the conceptual model is a kind of story. And this is a theme that I found again and again, that a conceptual model isn't a static structure, it's a story. And here much later, about 10 years later or so, is Kent Beck, talking about extreme programming, coming not from a manager's perspective or a psychologist, user interface designer's perspective, but from a programmer's perspective. And even there, he says that the overarching design aspect of a software system is what he calls the metaphor. And the metaphor is a story, again, rather like Don Norman's story. And he then says, this metaphor in extreme programming replaces much of what other people call architecture. Now, I don't think he means architecture in the software architecture sense of the essential organization of the system. I think he means architecture in Mitchell Kapoor's sense. So I've been very interested in trying to understand whether or not I could pursue this notion of concept or conceptual model. And so naturally, the first place I went was to a community that calls itself the Conceptual Modeling Community. And they have lots of wonderful research papers that I've learned a ton from. The only problem is I couldn't find there any notion of concept. And in fact, in a number of papers, it's pointed out, here's one from 2013. One common claim is that models represent concepts, but there's no clear articulation of what the concepts are. And if you look at those papers, there's sometimes an intimation that concepts, for example, are entities in an entity relationship model, or they're objects in an object-oriented system. And actually, I don't want to go into this today, but it doesn't take much thinking to realize that those will not suffice as concepts at all. So the desiderata that I was interested in, could I come up with a notion of concepts that allowed you to tell this compelling story, that gave you, importantly, a notion of reusable parts, so that the concepts weren't all munged together and tied to the system, that could build on Christopher Alexander's notion of patterns, that allowed you to do some deep analysis, maybe in the style of the kind of analysis we can do of user interfaces because of all the great work in heuristic evaluation, for example, that was formalized by people like Jacob Nielsen. And could we have underlying design principles for conceptual models in the same way that we have design principles for the design of physical user interfaces? So the idea that I came up with is perhaps not novel and perhaps very straightforward, and that's fine. But so I'll explain to you what this idea is. It's that software is essentially formed from concepts. And let me tell you what a concept is. So here is a rather self-serving, or at least family-supportive excerpt from Hacker News that happens to be discussing an old programming method called JSP. If you look at this site and trying to figure out what this site is, you actually won't have that much trouble because you'll eventually realize that this thing is a post. You see the login, you see these are going to be comments, right? Because they follow the post. This thing over here is clearly some kind of session concept because you see the word login, it's always in the top right-hand corner, right? You see here that this post has some number of points. So there's some kind of upvoting. And sure enough, if you go to the homepage, you'll see that's affecting the ranking of posts on the homepage. There's a favorite link there, which is, you might guess, is going to set things aside you might want to visit later. And if I click on a user, you'll see this user has some number of karma points. The only reason they can get away with using the word karma is because we're familiar with the karma concept, So my claim is that the reason we know how to use a website like this is not because we've seen this site before and this particular configuration of concepts, but because we've seen all these particular concepts before. So what is a concept? So let's take the concept of upvote. So the key thing that I identify in a concept is, first of all, following Christopher Alexander and the entire Gang of Four patents literature, giving it a name. So let's call this upvote. The purpose of upvoting is ranking items by popularity, by some kind of crowdsourcing. And here's the story. The story, roughly speaking, is that after some series of upvotes of items, and notice it's polymorphic, the items could be anything, the items are ranked by their number of upvotes. This idea of having a little story that describes the behavior of a machine is really essential to the work of the philosopher Michael Polanyi, where he calls it the operational principle of a machine. And I've adopted that term because although it sounds a little bit philosophical, I think it's quite apt. Now, the important thing to realize is you might be looking at this and say, oh, this is completely obvious. But let me point out to you that there's actually something a little deeper than you might imagine going on here. And we could look at some user interfaces that look very similar and actually recognize that they're very different concepts. So we look at this one, right? And this uses different arrows, but we can recognize once we play with this, that this, which I think is from Stack Overflow, some poor person struggling with their alloy homework, this is our old friend upvote, right? But look at this. This is from Slack, right? So Slack has a thumbs up. Is that upvote? No, it's not, right? Because when you click a thumbs up, it doesn't move the post up or anything like that. This is just a very basic kind of message. It's what I might call the reaction concept, right? Its purpose is to send reactions to the author of a post. Sometimes they're aggregated, but it's a trivially simple concept that the reactions are just shown to the author. How about this one? This is Netflix. And Netflix, again, we have a thumbs up and thumbs down. I'm looking at a TV series. And the question is, what is this? Is this upvote or reaction? What do you think?
It's upvote, but just for the viewer.
So for what purpose?
So that to rank similar TV shows for the viewer, not for
exactly right. So the key point in your answer was to rank similar things, right? So I might call this recommendation. And the purpose of this concept is to use prior likes to recommend items in the future, to recommend different ones. And the crucial notion is that we're going to rank categories or kinds of items. So although these all seem similar, they're in fact completely different concepts, even though they have similarities in their user interface. Now, this is the sort of nod to formal methods. Of course, when you want to really explore a concept in detail, you have to be able to describe its full behavior. And that's done by listing the actions, or this is one way you could do it. I think, in fact, it could be done in multiple ways, but this is the way that most appeals to me. So we could say that as a user of upvote, you can upvote an item, downvote it, or unvote a vote you've already issued. And then there's a state that supports those actions. And that state could be written textually, it could be written, as an entity relationship diagram. And then we could specify each action. So we could say, for example, a downvote is allowed when there isn't already a downvote for that item. We're going to remove all the votes that already exist for that item, whether they're upvotes or downvotes. We're going to add a new downvote for that item, and we're going to update the rank accordingly. Okay? So the idea is that we can describe these concepts in detail, and we could even build a catalog. Now, the interesting thing about the catalog is it includes not only the formal descriptions of the concepts, and here's where I really move away from my sort of formal methods upbringing. What I think is particularly interesting about these concepts is that they become carriers of contextual knowledge. So if you're an implementer of upvoting, for example, you don't probably have a lot of trouble implementing these simple actions and getting them right. Making sure you don't have bugs in your code, that an upvote really increases the vote by one and whatever. You probably have more trouble with these kinds of things. The fact, for example, that you have to prevent double voting by somehow identifying a user who's voting twice, whether through their IP address or maybe their Mac ID or maybe their username if they're logged in, right? You have to worry about things like old content getting promoted because it's been around for longer. So it's getting more votes. So it appears to be more desirable and it's pushing out the new content, but only because it's been around for so long, it's accumulated a lot of votes. So these kinds of things, these are at the interface between the concept and the human user and the context of usage. And in a way, they're the most important part of the concept. And what I imagine is that you could, in this catalog, have an enumeration of all the knowledge that we've gained about a concept and the design variants that address those particular concerns. So in short, a concept is really two different things. From the user's perspective, it's a behavioral protocol, right? It's this simple message. If you like something and you upvote it, then if enough people do that, it will move it up in the rankings. But from a software perspective, it's what I call a nano service. It's just a little service with an API. But it's a smaller service than the services we're used to. It's smaller than a microservice, which would typically be an aggregate of many concepts. Typically, a concept is generic. So in particular, you can upvote any kind of item. It's freestanding. So notice in particular, and I think this is really crucial, and the early literature on mental models points out how important this is, that concepts have to be understandable fully independently of one another, right? So the reason that I can understand upvoting is because I can take my knowledge of upvoting from one app to another, and it's not related to any other. I mean, obviously it interacts with the other concepts in the app, but I can understand it completely independently. And that ability to have independent mental models that describe each piece of the functionality independently of every other piece, I think is really crucial. And I'll have more to say about that in a minute. And then the third, of course, is that concepts are reusable. That if you figured out how to design upvotes, you can use them in any context in which you have some items you want to upvote, whether it's comments on a New York Times article or answers in a Q&A forum and so on. Now, the tricky thing about being freestanding is that we want both the concepts to be independent of one another in the sense that they can be defined independently, but we're eventually going to need to put them together. So the question is, how do we put them together without coupling them to one another? So that's the idea of composition. So let me illustrate how this is done. So here's our old friend upvote. And now suppose I want this behavior. This is actually a behavior in Hack and Use. I want to say you can't downvote an item until you've received some number of upvotes on your own items. Okay? Well, here's the bad way to do this. The bad way to do this is to note that this can be defined entirely within the upvote concept, right? Because it talks only about the actions of the upvote concept, and I could extend the state of the upvote concept accordingly to support this behavior. But as soon as you think about it a little bit more, you realize that that doesn't make any sense at all. First of all, I'm sort of corrupting the upvote concept by particularizing it for my application in a way that makes it non-standard. And secondly, what if I wanted to say you can't downvote an item until you've done some other nice things that aren't related to upvoting? Maybe until you've created your own post. Maybe until you've visited the site 100 times or something like that. And so that motivates the idea to say, well, maybe there's another concept at play here. And what you do in concept design is you ask yourself the question, is there already a concept for that? And indeed there is. That concept, is the karma concept. And so we could specify a karma concept that has, actions like a user contributes an item, a user gets some reward, and then an action permit that says a user is permitted to perform some action that requires some number of reward points. Now, this concept is a little bit strange because this permit action is sort of a placeholder. In order to achieve this separation, I'm just saying you're permitted to do something, but I'm not saying what you're permitted to do. And so let me show you now how we make that work. So the way we make it work is that we connect together the actions of the two concepts. So we say, for example, that when a user upvotes an item and the item was contributed by another user, that other user is rewarded. And then similarly, when a user performs a downvote, then it must be the case that at the same time, we also execute the permit action with, say, 20 karma points in the karma concept. So the way you should read these are not sequential. These are like transactions. They're all or nothing, right? This says you can't have a downvote without a permit. And this says you can't have an upvote under those conditions without a reward, okay? And so the way this would work in practice is, let's suppose, Alice contributes a post, Bob contributes a post, and then Bob upvotes Alice's post, right? The consequence of that, because of this synchronization, is now that Alice must get a reward. And now if Carol upvotes Alice's post as well, she gets another reward. And now Alice can be mean and downvote Bob's post because she has enough karma points to do that. Okay? So just like the formalism that I showed you for concepts a minute ago, there's nothing new here at all. This is in fact an old and very well-established idea of composing things that was introduced, maybe even preceded, but is best known from the process algebras CSP and CCS. And this is essentially a variant of the synchronization of events from communicating sequential processes. And the crucial point about this is that by connecting the concepts through these synchronizations, the concepts themselves are not coupled to one another. Any coupling between them is implicit, and the dependence is only, if you like, of the wrapper on the concepts that are composed inside that wrapper. And so we can draw a little picture of that. You can draw little pictures to explain how these concepts are put together. But a more interesting picture is this one. This is a picture that is a dependence diagram. And it's a bit of a paradox. I've told you that concepts aren't dependent on each other. But of course, in some sense, they are. They're not dependent on each other in the sense that you need to understand one in order to understand another. And they're not dependent on each other in the sense that the code of one concept involves calls to the code of another concept. But they are dependent on each other in the sense that sometimes it would make no sense to have one concept without another. So for example, there's no point in having comments if I don't have something to comment on. So if I look at the family of products that I could build around this Hacker News set of concepts, for example, I could, in the style of David Parnas, draw this diagram to specify the possible subsets that make sense. And that subset, for example, would include a very basic app that only had posts, and perhaps a subset that only had posts and comments, but not one that had comments and no posts, or not one that had replies and no comments, not one that had upvotes and no posts. And so this diagram is a diagram of the set of possible subsets, but it's not the diagram is not induced from the structure of the code itself. Now, interestingly, I think a question that, or an observation that's not been adequately realized is that the dependence diagram in software in general is not actually extractable from the code. People often talk about dependencies as if they are, but they're generally not. For the simple reason that there are often hidden couplings between different parts of the code, and they're dependent on the specifications. That's another subject that I have a little paper on in case you might be interested. So this is the notion of synchronization and how synchronization allows you to achieve essentially interaction at runtime without introducing coupling. Now, one of the things that I find interesting about synchronization is that it can be seen as a design move. So I've sometimes tried to formulate the way you think and what I do when I'm trying to pursue a conceptual design in terms of different moves you can make. And I wrote a paper a while back that identified 3 key pairs of moves. And one of them is what I call tighten, loosen. And basically the idea is that when you have 2 concepts, you can tighten or loosen the synchronization between them. And that essentially involves a trade-off between automation and flexibility. So let me give you a mechanical analogy. You know, we've all seen these, airplane loos. In a toilet in an airplane, there is a light pull, essentially, and there is a door lock. And they've coupled the 2 together. And they're coupled in such a way that you cannot lock the door you cannot turn the light on without locking the door, right? And so there's a loss of flexibility there. And the reason there's a loss of flexibility is because they don't want you to be embarrassed by thinking that you closed the door when you haven't. And so they signal that to you by not allowing you to turn on the light. But of course, the loss of flexibility means that I don't know how they handle the cleaner, but the cleaner presumably has to do something different to turn the light on, without locking the door. On the other hand, here's the move in the other direction. If you consider old rotary dimmer switches, I can barely even remember them, but I think many of them were like this. They would have a single dial that started off, and then you would click it on, and then you could set the brightness of the lamp. So this is a very strongly synchronized design between the on-off concept, if you like, and the brightness concept, and a much better design, which is a design of all dimmer switches now, is to actually undo that synchronization completely, allowing you to turn the light on and off while keeping the brightness setting at whatever level it is. So what I want to do is I just want to illustrate for you how interesting I think tightening can be in the context of software design. And what interests me in particular is how it brings something that I call synergy, where one concept really begins to sort of play a useful role for another one. So in Gmail, for example, the way you organize messages is by labels. So here, for example, we see a conversation which has some labels, hacking, meetups, and so on. These labels appear here, and I can click on any one of these labels, and it will show me all the messages with that label. What is really clever, let me see. What's really clever about Gmail, I don't quite have the slide I meant to have here, is that all of these different classifications are achieved by labeling. So whether a message is sent and whether or not it's in the trash is achieved by labeling. And so that means in particular, if we look at an example, there's a trash concept that we're all familiar with. It was invented essentially by the Macintosh in 1984. And these concepts are synchronized so that when you delete an item from the trash, it also adds the trash label to the item. And it's bidirectional. So that when you add the trash label, it puts it in the trash. And this is a much cleverer design than you might imagine, because what it means is that, for example, first of all, you don't need separate code for like finding stuff in the trash. But also it means, of course, you can form composite queries and labels. You can say, show me all the items in the trash, that are from Daniel Jackson or whatever, and it can do that. And so that's a very clever synergy. The synergy that I find perhaps most interesting, because it illustrates how difficult synergies can sometimes be, is the synergy that Apple pulled off, in which they took that trash concept, which abstractly is that you just have a set of items that are trashed, and they synchronize that with the concept of folder by essentially making the trash a folder. Now, you might say, well, isn't that completely obvious? But if you think about it, it's actually not obvious. It was an extremely clever design move. It turns out that Microsoft in the early days, when they first implemented their trash, they didn't do it that way. And when a folder was put in the trash, it disaggregated it. And all the files were put in separately. And then it had a clever algorithm for trying to reconstitute it if you took it out. And Apple had this very clever insight that you could simply move the folder into the trash folder, right? And that would be synchronized with trashing all the files in that folder recursively down the tree, right? But that actually turns out to be a rather troubled design move. And actually, if you look at a lot of synergies, you find that to make the synergy work, there had to be some tricky compromises. So let me just point out to you one or two compromises here. The first interesting one is that because there's only one trash for the whole system, this means that the trash holds files from multiple volumes. Now, most folders are not allowed to do that in a file system. You certainly can't do that in Unix, right? And furthermore, my folder here is called Western. All my folders are named after famous photographers. That's a bit obscure, but here I'm showing basically a grouping of files by volume. You can't do that in other folders. You can only do that in the trash folder. Here's another example of something that I think is this is, if you like, a troubled design move because it breaks an invariant about folders. One that I think is more in the spirit or more successfully in the spirit of synergy, which I really love, is this edition, which amazingly came only in 2011, which was about 30 years after the invention of the trash. And what Apple's engineers did, I think absolutely brilliantly, was they added a metadata item, a metadata field that indicated when a file or folder was added to a folder. Why is this important? Well, it's important, first of all, because it's a useful piece of information to have for a folder in general. But if you think about it, for the trash, it's the date of deletion. And before this point, believe it or not, there was no way to sort items in the trash by when they were deleted. And Apple, I think quite correctly, resisted adding a date of deletion column to the trash, which I believe Microsoft did add. Well, it's a difficult question, right? That would break the analogy even more. But this is a beautiful solution because it serves both the trash and folders in general. So that's the idea of composition. And what I wanted to do in closing was to try and give you a feeling for how I teach students how to use concept design. Sometimes I feel when I'm trying to explain these ideas that it's all a little bit philosophical. But actually, I think it has some quite simple implications for how we think about software, and sometimes allows you to think about software in different ways from the ways that we traditionally do that. And so the way that I'm presenting it to my students this term, at least, is through the lens of simplicity and using concepts as a way to help you seek simplicity. So why do we care about simplicity? So I think perhaps this, to some extent, this is sometimes a sort of academic industry divide. I'm firmly on the simplicity side of things. I remember I once visited Charles Simonyi at Microsoft many, many years ago, and he had a huge shelf of Windows manuals in his office. It must have been like 10, shelf feet long. And as a very cocky and rude, young software engineer, I said to him, how did he feel about that? And was he concerned about lack of simplicity in Windows? And he looked me straight in the eye and said, Daniel, simplicity is crap, which I thought was very interesting. And I think there is an argument that simplicity is sometimes overrated. But I very much like this observation from John Gall's very eccentric book, Systemantics. And what he essentially does, he'll grant you that you cannot be simple. But he says this, a complex system that works is invariably found to have evolved from a simple system that worked. A complex system designed from scratch never works and cannot be patched up to make it work. You have to start over with a working simple system. And I really believe this to be true. The world is a complex place. And if you build something real, it will be complex because you'll have to interact with complex people and complex organizations. But if you start out with self-imposed complexity, as if you like a self-inflicted wound, you'll never escape from it. And so for that reason, I believe it's very important to try and achieve simplicity, and concepts might help you do that. So let me just show you a couple of ways in which they can do that. The first is that you can just avoid inventing things. When you're trying to provide some feature, you can ask, is there a concept that already exists for that? So let me give you an example of that. In PowerPoint, this is right, yes. In PowerPoint, there is this concept of section. So that what you can do is you can divide your slides into sections. And that's obviously very useful because it allows you to impose some structure on your slide presentation. Unfortunately, you can only do it at one level. So you can't have sections inside sections. You can't have subsections. But worse than that, if you actually look at the menu for manipulating sections, it's sort of obvious what operations you're going to get, things like add section, but it's not at all clear what that's going to do. There's a tricky question about where the cursor lies. Sometimes your cursor can be a slide, sometimes it can be between slides. When you add a section, I don't even remember whether it adds it below, whether it adds it above, which slides get put into the section. It's all a bit of a mystery. And my understanding of the situation is it might be possible to design this better, but to some extent, if you want simplicity, you can't get there from here. Apple, on the other hand, did this. They simply produced this structure where you can nudge a slide to the right to essentially put it underneath another slide. Now, what was so brilliant about this and what makes it so compelling is not that it's just a better solution, although I think it is. It's that we all knew this. This is just the old outline concept, right? That we've seen in any kind of outlining tool, right? Normally for text, right? In which you can push things in and out. So we were already completely familiar with that, including with this folding notion. It was a familiar concept. And so it's completely natural. And you can predict very straightforwardly how this is going to behave. So if you can, don't try and invent something new, just try and steal something that already exists. The second thing you can do is you can eliminate redundancy. So as I mentioned, there's this label concept. Here are labels in macOS, and here are labels in Gmail, as I mentioned. Gmail introduced this notion of categories as a way of organizing your incoming messages into ones that were seen as coming from social media and sales pitches and so on. And these category tabs have various controls and so on. When categories came out, they did not get a universal approval from the blogosphere. Now, I think some of these criticisms are a little unfair. I think ugly, stupid, and unnecessary is a bit over the top. You know, bloggers get very excited. But this, I think, was a good point. Someone said, why are the tabs so confusing? They introduced a not so clear element in Gmail called categories. And then this person says, the problem is we already have labels. Why do we need categories? I've already come to understand what a label is. And they didn't say it, but they could have said, and I knew what labels were from Mac OS and a million other systems. Why did they not just go with labels? Well, I was in the early days of researching my book, I was curious to answer that question myself. And so I thought, well, let's look at Google's help facility and see how Google explains the difference between labels and categories. So I looked up labels, and here's what Google says. Using labels. Labels help you organize your messages into categories. Oops. To be fair to Google, I think this was a legacy help page. But the key point is that if we look at labels and categories, they have the same purpose, they have the same operational principle, but then they have these weird differences. You can't associate labels with tabs, but you can associate categories with tabs. You can't create new categories, but you can create new labels. You can apply labels outside the inbox, but not categories. And so the simple point is they didn't need to do this. They already in fact had a subset of labels called system labels that are attached automatically. They could have attached categorization labels for spam using labels in exactly the same way without inventing a new concept. So that's idea number 2, avoiding redundancy by making sure before you actually use a concept at all, whether or not you could use a concept you have. And the third category, the third idea is factoring concepts out. And this is slightly vaguer, but I've been having a lot of fun thinking recently about Zoom. And I want to just give you a little flavor of how you might apply sort of some concept ideas to Zoom. So Zoom has this reactions button. And if you open that up, you see this collection of reactions that you can issue. And in some sense, this is a straightforward concept. When you click on one of these things, it produces a little icon that comes up. So you might say, well, there's an operational principle, and the purpose is to somehow notify the other people in the chat. But once you start to think about these things, and there are many of them, you can clap, you can send love, you can say yes or no, slower or faster, you can say you're away, you can raise your hand and so on. The problem is that even Zoom realizes that these are not really a uniform concept, that they really fulfill different purposes. And that is evident in some of the weird anomalies. So for example, these emoji on the top row disappear after 10 seconds. This one, most notably, never disappears. And that's a cause of a lot of problems. These are mutually disjoint. Sort of makes sense, right? Maybe if I clap and then I say I really love someone, I want my clap to go away because I've upgraded my emoji. I don't know, right? It sort of makes sense. But weirdly, these are mutually disjoint too. So that means that if I asked my lecturer to go slower, and then my lecturer polled me, and I said yes, then my request to go slower disappears. And furthermore, if I leave and say I'm away, then all my votes disappear. And there's a clear feedback action, and it clears everything, but it doesn't clear these. Why not? These are counted. That makes a lot of sense, right? You almost certainly want to know how many people said yes to your poll, but do you want those to be counted? And so what this suggests is that the reason for these commonalities that we wouldn't expect and these anomalies, these non-uniformities, is that actually we have different concepts, and we might be able to identify different concepts by breaking them into groups. So for example, these at the top, I might say, well, these are really either a sort of reaction, or maybe they're just like a miniature chat concept, right? All you're really doing, in many chat apps, you can actually send an emoji. So maybe I could work those into the chat concept. These here are really a poll, right? This is feedback to a lecturer or a speaker, and these could be implemented completely separately. In particular, presumably these concepts I might want to turn off as a speaker, or only turn them on if there is even a speaker, even the kind of session where there is a speaker rather than just a meeting. And these, I think, are quite interesting. Raise hand and the coffee cup are really related to some kind of presence concept. And perhaps that's Zoom specific. And I think perhaps that's where the most interesting elements of design could be. In particular, I think these certainly, the poll and the chat, are familiar, and the others perhaps need some design. So here's just a little brainstormed, untested, I should say, because I'm well aware of how things in human-computer interaction design never quite work out the way you expect. But if I were going to do a user test, I would start with something like this. You know, I would probably put all the presence buttons, whether I want to talk, whether I'm speaking or listening, whether I'm away, in radio buttons, so that I couldn't find myself, for example, both speaking and still have my hand up. Furthermore, I at least sometimes feel I'm never really sure whether I'm properly muted, and having a simple toggle between speaking and listening would spare me that agony. I could put together the emoji with a chat widget, and this also raises interesting questions. Like, for example, what if the emoji appear on the tiles? Why don't the chat messages appear there too? Maybe they could. Maybe that would be nice in a small meeting, right? And then, for example, I could have a widget for polling like this that appears when the speaker wants it, you know, that displays the number of people who've chosen each option. I think you've probably had enough, so I won't go into the last thing, which is I think one can also do some quite interesting analyses of the underlying concepts in an app, in this case Zoom, and discover how concepts sometimes don't match up with conventional concepts in the way you'd expect. So in summary, the compelling story, I won't claim by any means to have solved the problems that I started out with, but I feel like I'm making some progress. The story is essentially, the story that's told by a concept is its operational principle. The reusable parts of these concepts, which are like nanoservices held together by synchronizations. The patterns correspond to the shared knowledge carried along with them. The deep analysis is afforded by essentially being able to do a modular analysis. So I can point to Dropbox and say, the problem here isn't Dropbox in general. It's not this user interface. It's that they adopted the Unix folder concept. And that folder concept has all kinds of very interesting merits, but it also has some serious problems associated with it. And then I've been trying to develop design principles. And one of the most basic ones is that purposes and concepts should be in one-to-one correspondence. And these examples that I showed you about redundancy and familiarity and overloading can all be understood to be a violation of that one-to-one principle. That the reaction concept, for example, in Zoom is serving multiple purposes. Then in Gmail, there's one purpose being served by two concepts, label and category. And in Keynote, that there's really one purpose that should be served by the same concept across apps, but isn't. So finally, a pitch from my book, and I'd be delighted to hear your thoughts now, and also just to say if we don't have time for a question or a reaction or whatever, then I have a little forum where I'm very happy to have discussions. So that's it. Yes.
Thanks. This was a very interesting talk. So I'm kind of curious about how these things extrapolate when, so you're advocating or you're talking about building concepts on previous concepts that people already know and are familiar with, and then how to avoid breaking certain invariants within those concepts. What happens when over longer time periods, you are essentially copying concepts that are no longer familiar to your audience? So the classical example is skeuomorphism, where people save files now by clicking on a diskette and no one knows what a diskette is anymore. But even using more modern concepts, I haven't used an actual paper file or folder in over 20 years, and many of my students are younger than that. So I assume many of them have never seen it. There's lots of concepts we use in files and folders that are not necessarily true in the original concept, like the whole concept of hierarchy. You wouldn't put folders inside folders beyond a baby too. What happens when you are copying something that is so old that you don't really know what you're copying, and you're really copying a concept at that point?
Well, I think it has to be fit for purpose. I think that's the short answer. It has to be fit for purpose and bring you enough benefit that if your users aren't familiar with it, it's worth teaching them. At least by using the old concept, if it's a concept that was implemented in software, you probably know that it's been debugged to some extent. And so at least it's not going to have a raft of new problems. But I think your point is well taken. I mean, I'm trying to remember what it is, but there's some concept that young people today apparently aren't familiar with. Maybe it's the concept of email or something like that, that from social media apps, they find the notion of email very hard to deal with.
That is true.
So I think you're right. I mean, but I will say, I think more often the problem is an old concept being broken. I mean, I'll give you one example. Apple just updated Apple Mail. Mm-hmm. And they added this wonderful idea, which is that you can undo the send of a message. And quite wisely, they synchronize that with their undo mechanism. So when you do undo send, it doesn't undo. When you do an undo, it doesn't undo send. Good so far. The problem is that they've broken undo. So if you send a message and then you do something else, and then you do an undo, it undoes the send, and you lose the ability to undo the last action you took. I mean, I can't imagine they're not going to fix this. It's so egregious. But I'm astonished that they published their software. This is in Ventura. I'm astonished they did this. This is a basic feature of undo. Everybody in the world expects undo to undo the last action and then to be able to redo it. You can't break that. I mean, that's my view. That's sacrosanct, right? That's what we understand by undo. So I think more often, I also think to some extent, I'm not sure skeuomorphism, how much it relies on actually you knowing the old thing and how much it's just an elegant way to present it, that people almost sometimes learn the physical things. But it's an interesting question you raise, and certainly one shouldn't be too glib about relying on concepts that people aren't familiar with, and there's a need to teach them. Yes.
I'm a big fan of patterns, and I've seen a lot of elements of patterns in your concept of concepts. I think there are two elements of patterns that I think would make this even more interesting, which are roles and refinement. Mm-hmm. So in patterns, there can be multiple different implementations of a pattern. For example, observer pattern, there can be push model and pull model, basically depending on which direction the interaction is happening. And when you talked about the different versions of concepts and kind of factoring out different kinds of concepts, I was thinking of basically applying the kind of refinement concept that we know from patterns as well to concepts. Like, for example, in karma, there can be the concept of karma that you have outlined where karma only increases. Right. But there could also be karma where karma decreases at some point. Yep. And at a higher level, they basically share the same kind of meta concept. Yep. And then have just different kind of refinements. No, absolutely.
I think you could certainly do that. And we're doing some work on dark patterns and thinking about that for things like shopping carts and what are the range of things you expect from a shopping cart. And indeed, there are exactly that. There are sort of variant shopping carts that do things that other shopping carts don't do. So I think that's entirely within the scope of what would be a valuable thing to pursue. That's a great point. Thank you.
There's a question from on the chat from
yes.
Bill sharing us about how does
Bill.
How does it compare with the old ideas related to feature interaction that were explored by Pamela and others?
Wow, what a fantastic question. I would say that, so the question is, how is this related to feature interaction? So I think I should first say how concepts are related to features. The first thing I would say is that the idea with features was generally that there's a sort of big piece of base functionality, and then the features are built on top of that as sort of special things. And so you're in classic telephony, I don't think you'd take as a feature the fact that you have a connected network or anything like that. The idea of concepts is that it's sort of concepts all the way down. So in Hacker News, for example, post is a concept. And I don't think Hacker News would advertise and say, hey, we've got this great post feature, use our social media app because we have posts. It's like, well, it wouldn't be a social media app if it didn't have posts. So the first thing is that there's a kind of uniformity in concepts that I think is different from features. The second thing I'd say is that features tend to be specific to the app, and I think there's been much less emphasis in the feature literature on making features that can carry from one application to another, that are truly reusable and polymorphic. And I think also features tend to be often dependent on one another, and the feature interaction literature allows for a very, very much richer form of interaction between features that I'm prepared to allow between concepts. And the result of that is that the simplification that I can attain with concepts comes at the cost of probably for example, in the telephony world, of having to put several features together into a single concept. Or to put it another way, I'm not quite sure whether I could support the richness of all the different features in telephony as separate concepts. I have some ideas, and actually in my book, I discuss, for example, I think in one of the endnotes, how call forwarding and plain calling could be separated as concepts. But I think there's some research to be done there. So in short, a feature interaction, I think, presupposes a much richer model of interaction, and concepts are in some ways simpler, perhaps more workable in many cases, but also less flexible.
Thank you. Any other questions?
Yes.
There was you had a slide earlier where you were talking about the thumbs up on Netflix, right? So, and you said that the concept is recommendation. So, my question is kind of similar to the feature one. Like, at what point do you realize you arrived at an nano service?
At another concept?
Yeah. How do you know you've arrived at a concept? Like, if it was up to me, I would have gone and said that the customer's reaction is probably one concept, which is abstract. And then another concept would be imbibing that into a recommendation, because a recommendation could be in different ways. Like YouTube used to have the 5 stars.
That's a really great question. I think the way you discover it is that you discover that a concept you thought was a concept turns out to have conflicts of purpose that you hadn't at first realized. So let me give you an example that I discuss in my book. Facebook likes. So when Facebook introduced what they actually call it reactions, when Facebook introduced reactions, people asked the following very natural question. If I mark a post with the angry emoticon, am I upvoting it or downvoting it? Right? Now, the reason they asked that question was because people implicitly understood that although Facebook was presenting this as a single concept, there are in fact multiple concepts at play here. There is some kind of reaction concept where you're simply telling the author, oh, I love that, that makes me sad or whatever. But they know there's upvoting going on as well. You're promoting the post. And so they're asking, tell me what the synchronization is between those concepts. The answer, it turned out, as we all know, is that the angry emoticon, along with many of the others, was like worth 5 upvotes or whatever. And that was a much criticized feature of Facebook's design. But the key point was there that once we started recognizing that complexity, we realized we didn't have a single concept at play. And I think that's what happens. It's not something that sort of emerges automatically, but as you sort of delve more deeply into the design of a concept and realize that there are complexities, you start to ask yourself the question, do I have the wrong concept here, or do I have multiple concepts? How could I simplify this? So it's not a solution. It's not a straightforward, solution, a panacea to every design problem. If you like, it's a sort of lens. It's a way of thinking about it that poses questions like, could my problem be here that I have more than one concept? Could my problem be here that I have the wrong concept? That I'm doing what I call piggybacking, that I'm pretending it's upvote, but it's really recommendation. Yes.
I was interested. So you talked about the conceptual models in the beginning of the talk. So do you think an added field like something like alignment, in which your concept is aligned with the user's expectation, could help in the redesign process? So apart from the purpose and action and other fields that you have, something like a score that keeps it in users' expectations could help in the redesign process.
You mean essentially to sort of measure the gap between the user's mental model and the concept?
Yeah, like there's a purpose, right? Like that it does that thing, but is the purpose aligned with the user's
with the user's actual needs?
Yeah.
Oh, that's very important. Yes. And I think that gets to a very interesting question, which is when you design an app, are your concepts, are the generic purposes of your concepts actually in the service of the right needs of the user? That's a critical question. Yes. And I haven't discussed that, but you're right. That will be essential in any conceptual design. Yes.
So toward the end of your talk, you talked about you gave some examples on the different stuff which say Apple did versus Microsoft when it came to the PowerPoint tool. And so my question really was, what are your thoughts behind the major drivers of why, say, Microsoft went for that particular design versus Apple? Because I'm sure all of them had talented set of engineers and designers, and Was it just laziness on their part to not think of it?
I know, it's certainly no laziness. I'm sure, as you say, the designers, the people who work at Microsoft are very talented. And I'm sure they work very hard at it. I suspect it's just a different culture, that Apple has a very deeply embedded culture of the usability and the sort of the user's model pervading the whole engineering process. And I suspect what happened at Microsoft is that it got delegated to some program manager who perhaps didn't have as much experience as some other members of the team. Maybe it evolved during the work of some programmer. And so it's more a sign of accidental evolution, that's my guess, rather than some very experienced designer saying, let's do it this way. So I think design like that often happens as much by accident as on purpose. Yes.
So the framework of concepts that you've discussed here feels like it's somewhat separated from implementation. It's more of a design level concept. But do you think that there's opportunity to tie this in with some more implementation level things? I know to illustrate the concept of these concepts, you used little functions like upvote and things earlier on. Do you see a way for those to become like maybe part of a library or something?
Absolutely, that's a great question. So yes, first of all, I think there's a very natural implementation of concepts as API endpoints, where each concept has its own data store, and the actions of the concept are the back-end routes, essentially, as they get called in web apps. My student Santiago Perez de Rosso, actually for his doctoral thesis, built a platform for constructing apps from a concept library, where you could sort of write a little script that was like a front-end script that essentially invoked pre-built back-end concepts to do exactly what you're suggesting, so that you could build an app from doing that. It's not completely a solved problem for how you can build all the interactions you want in that way. But I think it's a promising way to build apps. And in our own software engineering course, we tell the students to build their concepts separately with their own schemas, in their own modules, with their own routes and everything. And they don't seem to have any trouble doing that. It's a great question. Thank you for bringing that up. Yes.
You talked about reusing concepts. For instance, Google should have used labels for categorization. But what do you think about building upon concepts? For instance, categories, they enable tabs, the appearance of tabs. So what if I use labels, but then at the same time, I define something called categories, which also had tabs on labels? What do you think about a design pattern like that?
That's an interesting question. I mean, this gets to the earlier question about refinement and extension. I would say that my understanding is that users probably don't want to deal with that. They probably want to know that there's one concept in your app, and maybe you've enriched it with respect to that concept in another app, but they probably don't want to see two variants of that concept within the same app. I think as a Gmail user, I would be happier to have that enriched concept to handle both the functionality of labels and the extended functionality of categories, and to have it done uniformly, so that I would never have to know the difference between a label and a category.
One more question, maybe.
In the example of the freezer, I realized that the concept that is shown to the user can actually be somewhat decoupled from the concept of the implementation. If you only have one thermostat, you could still present the who dials and then somehow like mathematically kind of map the concept you're showing to the user to the actual underlying implementation concept. Is this something that generalizes beyond just this one example?
You mean in the sense that you could, well, I think you mean in the sense that you could construct a mapping that was more faithful.
Yes.
I think that's implicit in Don Norman's work. And in my book, abusing Don Norman's term, he means something different by mapping. I call this the mapping problem. That basically you have an underlying concept and you want to map it faithfully to the user interface. And to some extent, the more isomorphically you do it, the easier it will be for users to understand. And so I think there is a discipline of mapping to be explored there. I think in a lot of user interface design, people say that the design has to present the right system image, but because there's no concrete definition of the underlying concepts, you can't even point to something that you have to map to. And so I think maybe concept design can help you do that. You can say, look, here's the concept, here's its state, here are the actions, where do these fall out in the user interface? And so you can ask, this allows you to ask very straightforward questions. You can ask, where is unvote in the user interface? And the answer often is, well, in hack and use, it needs to be somewhere different because not everybody can downvote. But in the New York Times, for example, a downvote is an unvote when you've upvoted, right? Actually, that's not true. It's a toggle. In some systems, it's a downvote. In some systems, it's a toggle. It can be different things, but we can point. The point is that we can identify that action unvote, and we can say, where is that in the user interface, and does the user understand that it's there?
All right. Well, let's thank Daniel for.
Thank you so much. Thanks for being such a great audience. Your questions are fantastic.